Topic: Electric field 1. An electric field is defined as a region in a space where electric force of attraction or repulsion is felt or experienced. Electric charges could be positive or negative. Electric lines of force. These are imaginary lines which show the direction a free positive charge will follow when placed in the electric field. Law of static electricity. This law states that like charges repel, while unlike charges attract. Conductors. Conductors are material that can allow the flow of heat and electricity through them. Insulators. Insulators are material that does not allow the flow of heat and electricity through them. Example: dry wood, plastics, etc. The gold leaf electroscope. An electroscope is a device used to detect small electric charges. Charging an electroscope. Electroscope can be charged by the following method: 1. By contact. 2. By electrostatic induction. Electric circuit. An electric circuit is defined as the path provided for the flow of electric current. There are 3 main types of electric circuit: an open circuit in which current flows to the external load, and a closed circuit in which current does not flow to the external load, and a short circuit that has no load at all, only connecting wires. Potential difference, PD. This is defined as the work done in moving a unit charge from one point to another point in the electric field, denoted as V equals W over Q, where W is the work and Q is the charge. Defects of the cell. Number 1, polarization. This occurs when hydrogen bubbles emitted from the electrolyte ionizes the cell and makes it fat and wet. Such battery cannot be reactivated, rather can be thrown away. Local action. Local action is caused by the weakening of the materials of the acid, and it can be reduced by amalgamation, while polarization can be reduced by using depolarizer such as manganese 4 oxide, MnO2. Resistance. Resistance is defined as an opposition to the flow of current, while a resistor is a device that opposes electric current. Examples of resistors include variable resistor, fixed resistor, resistant box, etc. Ohm's law. Ohm's law states that provided that the temperature and other physical properties of an electrical conductor are kept constant, that the current that flows through a metallic conductor varies directly as the potential difference. Ohm's law can be expressed as follows: I equals V over R. Graphically, V is the vertical axis and I is the horizontal axis. Factors affecting electrical resistance. The following are the factors that can affect electrical resistance. 1. The length of the wire. If a wire is so long, the current that it can carry will be small because the wire itself will use some part of the current. Number 2, cross-sectional area. If a wire is so thick or so large, it will also affect the amount of current flowing through it. Temperature. When the temperature is so high, it can lead to spark in wires, and also type of material known as the resistivity of the wire. Resistance can be given as resistivity times L over the area. If I cross multiply, resistivity equals RA over L, where R is the resistance of the wire, and A is the cross-sectional area, and L is the length of the wire. Resistivity. This is defined as the resistance of a wire of unit length per unit cross-sectional area. Conductivity. This is defined as the extent to which a material can allow current to flow through it. Conductivity is denoted as 1 over resistivity equals L over RA. V equals W over Q. That is potential difference equal to work over charge. If I cross multiply, work is equal to QV. Then work equal to IVT, since charge is equal to IT. Using Ohm's law, V is equal to IR. Then heat energy is equal to I squared RT. This is the heat generated by electrical energies such as electrical iron, electrical oven. In fact, all electrical devices that can convert electrical energy to heat energy. The heat energy is given as I squared RT or IVT. Electrical power. Electrical power is defined as the product of the current and the voltage. It can also be given as V squared over R or I squared R. Arrangement of resistors. Resistors can be arranged in two ways: parallel arrangement and series arrangement. For parallel arrangement, the equivalent resistance is given as 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3 and so on. While for series, the equivalent resistance can be given as R equal to R1 plus R2 plus R3 and so on. Buying and selling of electrical power. The cost of running appliances in our homes is given as PT over 1000 times kilowatt hour, where P is the power, T is the time rather, and kilowatt hour is the cost of unit charge. Coulomb's law. This law states that the force of attraction between two charges, big Q and small q, separated by a distance r, is directly proportional to the product of the charges and inversely proportional to the square of the distance apart, expressed as follows: F equal KQQ over R squared, where K is a constant called the permittivity of free space, which is 1 over pi E naught. So F equals 1 over pi E naught big Q times small q over R squared. Electric field intensity E. This is defined as force per charge. The unit is Newton per coulomb. Electric potential V. This is defined as the work done per charge. So electric potential is equal to Q over 4 pi E naught R. Questions. Number 1. What amount of charge flows in a wire if a current of 2 ampere flows in 4 seconds? Solution. Q equals 2 times 4 equals 8 coulombs. Questions. 2. What amount of heat flows through an electrical laundry iron which takes a current of 2 amperes and whose resistance is 4 ohms in 2 minutes? Solution. H equals to I squared RT. So H equals 2 squared times 4 times 2 times 6. We'll multiply through. We have 1920 joules. Number 3. What amount of current flows through a material whose power is 60 watts and voltage is 10 volts? Solution. P equals IV. 60 equals I times 10. Then I equals 6 amperes. Number 4. What is the power dissipated in a material whose current is 2 amperes and resistance 4 ohms? Solution. Power is equal to I squared R equals 2 squared times 4. That is 16 watts. Number 5. What is the power of a cable of voltage 8 volts and resistance 4 ohms? Solution. Power is equal to V squared over R equals 8 squared over 4 equals 16 watts. Number 6. 5 60-watt bulbs and 10 100-watt bulbs are run in a home for 4 hours. If PHCN charges 2 naira per kilowatt hour, what is the cost of running the bulbs? Solution. Cost equal to PT over 1000 times kilowatt hour. 5 times 60 plus 10 times 100 times 4 over 1000 then times 2 naira equals 300 plus 1000 times 4. Our answer is 10.4 naira for 4 hours. Number 7. What is the resistance of a material whose current of 6 ampere flows through and voltage 240 volts? Solution. I equals V over R. 6 equals 240 over R. We will cross multiply. R equals 240 over 6, which is 40 ohms. Number 8. What is the force of attraction between 2 charges, 2 coulombs and 4 coulombs, separated by 4 centimeters? Solution. F equal to KQQ over R squared equals 1 over 4 pi E naught times 2 times 4 over 0.04 squared. We will simplify and divide. Our answer becomes 4.5 times 10 to the power 13 Newton. Capacitors and capacitance. A capacitor is an electrical device that stores charges. A capacitor is made up of two parallel plates, positive and negative plates, and an insulating material separating the two. The capacitance of a capacitor. This is defined as the ratio of the charge to the voltage. That is C equals Q over V. When cross multiplied, Q equals CV. Arrangement of capacitors. Unlike the resistors, when capacitors are arranged in series, their total capacitance is given as 1 over C equals 1 over C1 plus 1 over C2 plus 1 over C3 and so on. While in parallel, their total capacitance will be C1 plus C2 plus C3 and so on. Energy stored in a capacitor. The energy stored in a capacitor is given as half CV squared or half Q squared over C. Question. Two capacitors, 2 microfarad and 3 microfarad connected in series across a terminal PD of 10 volts. Determine A, the charge through them. B, the energy stored. Solution. Since they are connected in series, 1 over C equals 1 over 2 plus 1 over 3. When we simplify and cross multiply, we have 6 over 5 microfarads. Then the charge equals CV, which is 6 over 5 times 10, which is 12 coulombs. B, the energy stored is equal to half CV squared, equals half times 6 over 5 times 10 squared, equals 60 joules when simplified. Or half Q squared over C equals half times 12 squared over 6 over 5 equals 60 joules when simplified. That brings us to the end of the topic, electric field 1.